Hello everyone, my name is Kostoprem Koshik along with my project partner Kolpojit Borua is here to present on our final year topic that is Helopeltis and red spider tea leaf disease detection using deep learning procedure. Under the supervision of Dr. Anjan Kumar Talukdar sir and the Professor Kondroba Kumar Sharma sir and under the co-guidance of Dr. Surajit Dega sir. Here is the outline of our project. At first, the introduction, the motivation, literature review, the objective, the problem formation, work done. First, the CNN-based method for the classification of rare tea leaf disease. Then, the design and implementation of advanced algorithm, that is yellow V8 for the disease detection part. And then the result and the discussions, conclusion, limitations, future directions, pie chart, and references. Introduction. Tea is an integral part of daily life for millions. It's a vital of our day-to-day lives. In Assam, tea is an essential part of our culture and economy. Its impact felt across various aspects and states' economy, contributing to its growth and development. According to the reports of January 2023, Assam has produced around 50% of India's total tea output, and India was one of the largest tea producers in the world. Assam plays a very important role in making India one of the world's largest tea sellers for several reasons, such as tea cultivation area, high quality tea varieties. Assam is renowned for the producing some of the finest black tea in the world. The tea production is good in Assam because of the climate. There are also many challenges faced by the tea plantations by our tea planters in Assam. Like all tea plants, tea bushes and leaves can fall victim of diseases that can harm their growth and quality of the tea. Disease detection in tea leaves and classification is a crucial to protect those tea industries. Due to pest attack and other diseases every year, small and large tea gardens and the other industry faces a lot of loss in their production. Infected tea bushes and leaves are often produces fewer leaves, which means lower production and less revenue generated from our tea estates. Critical need for the early detection that the leaves are like catching problems before they become big. It's a way to find the issue to helping farmers to take quick action to protect their tea plants. In our project, we are using various methods for detection and classification to make this procedure faster and more accurate. So next, the role of deep learning in agriculture. Nowadays, modern advanced technologies like computer vision and deep learning techniques have revolutionized in such a way to detect and classify and monitor these diseases in plant leaves. Convolutional neural network, yellow V8, and other deep learning algorithms have been instrumental in automating enhance the accuracy of disease detection in tea leaves. Deep learning model including CNN and Yellow V8 are trained on a dataset based on the disease. Next, the motivation part. In the motivation, we can say that the economic impact in tea industry is about more than just a cup of a tea. It affects the livelihoods of farmers and all over the economy. Tea cultivation is a vital sector of agriculture contributing the significant to our economy. In high competitive goals of tea market, any reduction in the quality or the quantity can put tea estates in disadvantage compared to other tea producing regions. This can lead a market share loss and reduces their earning. Motivation by the limitation of the traditional methods. Nowadays, technology has grown much more way. The traditional methods needs a much better way to find to fix those problems. Traditional approaches have a limitations, and we have been driving to overcome them using the innovative solution in our project using deep learning methods. Importance of food security. The importance of food security is about making sense everyone has enough safe and nutrition food to eat. It's not just about having a food but having a right kind of food to stay healthy. Our project is inspired by the role of food security aiming to contribute the solution for a world where everyone has access to the food they need. This is the literature review section. We have gone through those papers. In the paper number one, which is automatic detection of TLIP using the deep convolution neural network. Uh, they had proposed a work to classify and improve the accuracy of correctly predicting the diseases. They proposed the model considering several TLIP diseases and achieved the correctly identification of 94.45% accuracy. In paper number 2, there is the grave blight diseases detection on TLIPs using improved deep learning and CNN. They have proposed a TLIP disease detection model which is completely intelligent algorithm such as PCN multi-class SVM. The third paper we have cited, that one is the integrated learning based on disease detection method of TLIPs. Uh, in order to carry out the effective pest and disease identification, they have choose the yellow B5 model, which is widely used in the field of target detection. The objectives. Uh, our main objective is to develop a robust disease detection model to achieve the higher accuracy and precision and enable to the early detection and the invention part. To the primary goal of our project is also ensure that the disease detection in the system is a super accurate and precise using deep learning, CNN technology, and other algorithms such as Yellow V8. We aim to create a smart tool such as spot the problems in TLIPs with higher accuracy. Early detection of objects by using the deep learning method, we are developing a smart system to quickly detect the issues like the red spider and helopeltis. This detection is important because it allows the farmer to step early, taking action to produce thick crops before problem get bigger. Problem formulation. Problem formulation. In the first phase of our beginning the project, we have designed a CNN based model for the detection of those two diseases that are red spider and helopeltis. At first, we have using the CNN model, we have classified those diseases. In the second phase, we have designed and implement an advanced algorithm which is very much popular in the modern world. That is the yellow V8. The yellow V8 model is much more advanced than the CNN and RCNN models. This algorithm we use for the detection part for those diseases, the red spider and helopeltis. Design of CNN based method for rare TLIP disease detection. It is the block diagram of our detection classification part from our model CNN. Here we can see that from starting we have the part of the data acquisition and then data processing. We have collected the data, raw data from the local tea gardens of Assam. We have gone through those tea gardens. We have collected. We have clicked the pictures from the various regions and various sections of this tea garden using our mobile camera, and then we have pre-processed the data. We have pre-processed the data in the first part we manually. We didn't use any kind of AI tools or any kind of websites. We have just pre-processed the data using cropping, and also we have selected the data by with the help of our mobile by deleting those unnecessary data from the data set. Then we have done the part data annotation and data labeling. In those part we have manually label and data. We have created separate folders for those separate diseases, and we have successfully created those two labeling data with two different folders, namely the red spider and helopeltis. Then we, with the help of the code, we done the data augmentation part where we have expand our data set, and finally we have prepared our dataset, and our dataset is ready to train to use in the CNN training model. And in the CNN training model we have also make two classes, namely the first class, that is the helopeltis, and second class is namely we have make the three sections. There are three sections are validation, training and test. We have put those datasets on the validation class, training class and testing class. And after that, the we have trained our model from the validation portion and the training. We have got those the accuracy loss, confusion metrics and other parameters which we can gain from the CNN model. And finally, after the training and testing of those data from those dataset, and our model gives us the classification result, that our model able to successfully classify those diseases that are helopeltis and its spider successfully. And here it goes to the methodology part. In the methodology part, this the first step came, that is the data collection and the annotation part. As I have mentioned earlier, that we have visited the local tea gardens of Assam to collect those tea, to collect those leaves that are infected from those diseases. We have mainly aimed two diseases, that the first disease, that is the red spider, and second is the helopeltis. We have aimed these two diseases as because these two diseases affect a lot every year in the region of Assam. In the region of Assam, we can see that the every tea gardens, the small tea gardens and the large tea gardens are basically affected by these two diseases. And for this, the tea gardens owners and the manufacturing lost a huge amount of revenue. Therefore, we have aimed specially these two diseases. And here is the photo we have pasted, how we have collected and annotated the data. Second step in the methodology, that is the data augmentation part. In this process, we have used the ML for training the data set, and we have used this data augmentation part because it is very much necessary. It's a very important process to make our data set. This process to training the data set by applying those code, it makes the data set in a large number, and which we can able to get a accurate and more precise result. Now directly we came to the convolution neural network part. A CNN is a multi-layer artificial neural network which is composed of three crucial layers. The first layer, that is the convolution layer, the second layer is the pooling layer, and third layer is the fully connected layer. The convolution layer extracts the various features from the input image by applying the convolution operation. Also, those pooling layer, it